Awesome. So I think all of you have heard about responsible AI in 1 year's talk, right? So I have a few questions for you. And before that, let me introduce myself. So my name is Nisha Gambhir. I work in AWS as a senior consultant in AI ML team. So I help customers develop, design all the agentic AI ML, core data science, all that kind of fancy stuff, right? Indu, you want to introduce yourself?
Myself, Indu Teja, I think, yeah, I'm audible, right?
You can stay at the podium.
Okay. Yeah, so I'm Indu Teja and I'm also working for AWS as a senior delivery consultant. So I predominantly help my customers migrate their databases from different sources to different targets. Yeah, that's about me. So I hope you have an interesting session today.
Okay, so I have a few questions for you. So how many of you knows what is responsible AI? Nobody?
Yeah, then
Some?
this is for you.
Okay. I think, okay, what do you think who is accountable for the outcomes that your AI produces, that somebody, you think is accountable, that it is responsible? Everyone? Any other answers? No one? Sorry? Data. Okay, when you say data, is there a team that you're referring to, or data in itself is nothing, right? You use. Okay. Yeah, so your output depends upon the input, right? I'm talking about an overall conceptual. You could have different kind of AI systems, right? So who do you think is accountable that the outcomes you receive from the AI is responsible? Everyone, right? Sometimes maybe more responsible or more accountable than others, but essentially it's everybody who is working in that company, right? Okay, let's move forward. So we are going to talk about what makes an AI responsible, right? What is responsible AI? Why do we even need it, right? We have a lot of AI systems out there. Why do we need responsible AI? Why do we want it to be responsible, right? So we are going to talk about it, and then how to implement it in PostgreSQL specifically. And I'm also going to talk about how in general it's applicable to agentic AI systems. Right, so this is the agenda. I kind of already talked about it. So let's move forward. Yeah, I will hand off to Indu to cover a few slides.
Yeah. So before deep diving into the actual topic, so I just want to take a minute to talk about where we are with the AI journey. So we all know AI has brought in a lot of innovation, right? So it has unlocked the automation. It has helped us improve the efficiency, productivity, whatnot. I think everybody started using AI tools, right? How many have not yet started in the AI world? Anybody? No, right? So it has actually occupied us so much that we are now every day our part of life is with AI, right? I'm audible?
No.
Yeah, so with that, so it brings a lot of innovation, correct? So at the same time, I just want to make a cautious statement that it has also brought in a lot of risks and challenges. So that is what we are going to talk about today with our topic, how we have to be responsible in using AI. So that's the topic about being responsible, and we'll move on to the next.
Yes, sir, your mic is not on. Your mic is on.
So I just wanted to go through some of the examples on what are those risks and challenges. So there are pretty more, but just I'll take one or two. So the first top left, if you could see, it's an airline industry. So a passenger tried to book a ticket, okay. He had some emergency and he had to book a ticket, and he has used the chatbot. And chatbot, the underlying is all AI. So using that, he has tried to book a ticket and he has routed through some steps and followed, and then finally he got the ticket. That's fine. But what he ended up is like, when he followed the route of chatbot, he ended up paying more, almost double the charges what he had when he would have done to a routine process. So is it not, disturbing the reputation of the organization, right? So like that, we have many examples. Like, do you like a HR tool, hiring tool, and the tool is actually shortlisting the candidates, let's say female or male candidates. Do you like that? No, right? So, but why is the system behaving like that? Because it's been trained with some data, historical data, and that data is actually invoking the AI to select the candidate. So, this actually disturbs, or I would say, disturbs the trust, loyalty, as well as, there's a lot of, even it would be as devastating as it would damage the reputation of the organization as well. So what we have to do with these risks and challenges? So that's wherein the responsible AI comes in picture. So before that, I just wanted to take a minute to talk about some of the studies. If you see, 80% of the companies who have invested their revenue or amount into the AI or whatever, they are developing so many tools, right? So 80% of the organization who has been using this AI, out of which is just only 2% of the organization are actually implementing the responsible AI. Do you think there is a huge potential gap, right? So it invokes lots of risks and challenges. So see the gap, only 2%. And other study, if you see, 82% of organizations who has developed their tools with AI and matured their approach with responsible AI, out of which there is a 25% of increase in their loyalty and trust to the customers. So you can see, so while you have your framework, the responsible AI framework implemented in your AI life cycle, it's going to build up the trust and loyalty with the customer. So that is what now the definition comes in. So what is responsible AI? Responsible AI is the practice of designing, developing and using the AI technology with the goal of maximizing the benefits and reducing the risk. So it is very essential, very important. It's not that we use AI, but it is also very much important how you are using the AI responsibly, right? So in AWS, we have many core, I would say the core dimensions which defines the responsible AI. That is what we are going to talk about. So these are some of the responsible AI principles, like controllability, privacy and security, safety, fairness, veracity and robustness, explainability, transparency and governance. But being part of an organization, some comes with default, like privacy and security, safety, governance, right? So many organizations follow that. So they have the code of conduct to have the safety for the employees, or they have the regulations and governance, compliance kind of stuff which help them. But for AI, there are other dimensions as well which we have to take care. So when you get in, when you double click on each of them, so I just want to take a minute on some of these core dimensions like fairness. So what is fairness meant is, these are the risks which happens on a group of certain group. Let's say there is a biasing on a group. So the example which I gave for the HR hiring tool. So if it is going to just select or shortlist the male candidates, so it's biasing, right? So that's about fairness. How can we avoid that? And what is the framework which we can build to avoid those? That is what we'll talk about later. But yeah, that is all about the fairness. Same way, if you see the veracity and robustness, so that is about the hallucinations. So how consistent is the outcome? So when you give, when you just give a prompt, is it going to give the same answer, similar answer, I would say, or is it the outcome is changing? So those are some of the things which we have to take care. Privacy and security, safety. So you are trying to question, let's take a GPT tool, any GPT. You are trying to ask something illegal. Is it going to answer? Did anyone try? It should not. So those are some of the controls which we have to build in to make the system responsible, behave responsible to our prompts. So that is all about the responsible AI. Having said that, I'll just hand over to Nisha to take over how to integrate this responsible AI in the Postgres.
Yeah, just giving few more example of, for example, fairness, right? So the way we evaluate is, right, so specifically in fairness, depending upon the use case, you would look at, say, a parity of outcomes versus parity of performance, right? So for example, in an HR system, right, the same example, right, what are the candidates that are being selected or for interviews, for example, right? Now, the way we would evaluate is the parity of outcomes, right? So we should give equal chance to all different kind of candidates rather than selecting a particular groups of candidates, right? So, and in another use case, say a disease or maybe a cancer detection system, right? We give more importance to parity of predictions, right? Parity of accuracy, essentially, which comes under parity of performance, right? So there we give importance to the results versus the group of people, right? So whether the person is, say, black or white, right? Rather than that, we give importance to the performance, whether the correct person is detected, if the person actually has cancer, right? That's the one is being detected as one, right? Rather than the other way around. So the result matters more, the accuracy matters more rather than the group of people. So depending upon the use case, right, depending upon the system, whom you are building the system for, some of the parameters becomes more important than the other. So it's very important to even understand the domain when responsible AI comes into the picture and different dimensions of it, as Indu was explaining. Now let's get into some more details on some of the other dimensions, right? For example, explainability. Now, explainability tells you what is the outcome that you have received, how did you actually receive it, right? What are the parameters that was, or the features that was used in order to came to the outcome that was given to you, right? So, for example, in a Gen AI system, right, you have the input that you give, you ask a question, you get an answer. Do you know how you got that answer? What did model think or how did it arrive to that outcome, right? So explainability basically gives or helps you arrive or know how you arrive to that answer, right? And then interpretability, right? It's about understanding the underlying logic. How did model was trained to arrive to that particular logic? And a lot of these things comes into picture when model is being trained and evaluated before it is put into the actual system, right? Actual production. Right, so let's get into some more details on how this is implemented, right? So a very common way to know the explainability is using Shapley, something called Shapley, right? Some of you, if you have studied data science, would know about how Shapley works, right? So this is a formula of it. Basically, the thing is like you define a feature, right? And you evaluate all the features. You come to know which features are important to get this outcome, right? So this helps you identify the feature importance. So let's say in your data you have 10 different columns, right, to simplify it. Now out of the 10 different columns, how much importance is being given to that particular column, right? Let's take the same example of HR system selecting candidates for interviews. Now, if you have a column called gender, for example, right, how important is that column to determine whether that candidate will be called for an interview or not, right? So this Shapley analysis helps you determine that. So you basically, put all the features that you have and then determine whether that feature is important. How important is that feature, right? And then you have something called global exploration and local explorations as well in Shapley. It actually helps you determine both, but it mainly concentrate on the local ones. Right? There is another algorithm called line that actually works on the global exploration rather than local. So depending upon what you're trying to do and during training and evaluation, you use these different techniques to know how important your features are and then use it, evaluate the system, find out if your model is biased towards some particular group of people, some particular group of demographics, right? All those kind of things. And depending upon the use case that you are trying to solve, these things would vary. Right? So you need to make all these as part of your evaluation. And before ideally you put the system into production, and even after production, right, as we looked at in the previous talk, this is a continuous process, right? Depending upon how your system is behaving in the actual production, you need to continue, evaluate it, get the user feedback, analyze it, incorporate it in your model training the next time, right? Because even model training is a continuous process. Right, so this is an example on how you would implement this in Postgres, for example, right? So you would have something called an AI prediction table, for example, right? Wherein any prediction you are making, right? Now this is an example of prediction. It could be classification. It could be any kind of a problem you are trying to solve. The point being here is you would save the data in Postgres along with the prediction, the confidence score, and the explanation in the database so that you can find out when something is happening to know why that is happening. Right? Going back to the same example of candidate selection. So let's say a candidate was selected based on a gender. You identified that gender is one of the features that is given more importance. You can actually find out from this table why that could be the case if you are using a generative AI model, for example, or if you are using even other AI models. This explanation column that you see, right? Yeah, this one. JSON B basically contains a JSON structured data that tells you, the reasoning behind it, right? And if especially you are using a generative AI model, reasoning model that is, it can give you a reason of, that particular outcome. So you will store all that in your database, and especially for a regulatory industry like financial based organization, banks, insurance and all that, this is very important because they need the complete audit trail, they need the complete governance, right? So tomorrow if somebody asks, some auditing happens and somebody asks you, how did you arrive to this outcome? If you don't have this data, you don't know what has happened. Right now, observability also comes into picture. Right? If you're tracing your system end to end, right? If a user sent a request, you would have something called, say, a trace ID, user ID, other metadata. You can figure out when this request came, what all happened in your system. Right? So observability becomes very important, right? This is also part of it as to how you are saving that data. There are different ways, right? This is how you would do it in Postgres. There are different ways you can do it in different systems, right? There are different observability systems out there, different cloud providers and different APM tools. Okay. Yeah, now coming to interpretability, right? Now, if let's say you train a model, you deploy that model is not behaving correctly. Now tomorrow you train the model again on a different data set, you deploy the model again, right? If you do not maintain different versions of the model and even different versions of the data, you don't know what's wrong with it. You don't even have that data and have that model now, right? You may have that data, right, again depending upon how you are managing it, but if you don't have a trained model, you have to either train the model again with the same exact set of parameters, because end of the day, it's mathematical functions that are being executed, right? So you can expect to get the same results, but you will be wasting compute again, right? Which in turn is like you are wasting money, right? So you should always keep a version of your model, version of your data, so that if you were to determine something tomorrow, right, due to auditing requirements, governance, you would be able to figure out what versions you have used of the model and of the data. And that's where this comes into picture, like immutable snapshots, right? You could have a view or a materialized view created in Postgres which contains your version of the data that was used for the training, right? Training data can come from different data sources. Postgres is one of the sources, right? You could have other sources. So depending upon the kind of data source you are using, you would maintain different versions of the data. Same goes for model, right? You have to maintain the version of model. So one trained version that you have tested, keep a version of that model, evaluation results, right? All the weights, all the artifacts that you got. In order to figure out later in the future if something happened, why it has happened, right? You will be able to give that answers based on, the things that you have kept. Now, same we looked at RAG in our previous talk, right? Now there is something called interpretable vector search, right? So if you are using PG vector is an extension that you could install in Postgres database to make it as a vector database, wherein you can actually use Postgres to store your embeddings, right? Now if you use that to make this interpretable, you basically don't just return the results, you return the distance also, right? The way you return the results based on the type of chunking strategy you use and the based on type of retrieval you use, you would be using some kind of a mathematical function to retrieve the results, right? So I'll give you an example of semantic search, for example. In that semantic search, you generally use some kind of a distance function, right? Cosine similarity, for example, or a Euclidean distance and all that. And you would have a distance matrix, which tells you how far this particular data is from the query that you have, right? And based on that, you would have different documents retrieved from RAG, which will have a rank, right? And then you return that. Now, don't just return that, return the distance also. Now, here when I say return, it doesn't mean to the end user. It could be just storing that in the database somewhere so that later on, it can be used to understand why that result was retrieved, right? And then there is something called segmented embeddings as well, wherein you store the vectors for different features, right? Rather than just combining all features and storing vectors as a one set of vectors, you basically store vectors for different features separately so that you can then explain what features played most of the part in the decision that was made when the retrieval happened and a certain set of data was returned, right? So these are different techniques, right? You would have to kind of test different techniques to figure out what results are the one you are most expecting. And again, as I said previously, it depends upon your use case, the kind of data you are using, what kind of results you are expecting, and this is a continuous process. Responsible AI is not just technical, it's more like a socio-technical, wherein people, processes, continuous monitoring, observability, governance, right, security, privacy, everything comes into picture. And not all of them can be implemented just technically, right? Your organization has to have a culture of being responsible, right? Even if a person at a lower level in the company, if they see something coming back in the outcome, in the result, which doesn't, kind of correlate to what is expected, they should report it. They should give a feedback. That's what responsibility, accountability mean for them, right? So responsible AI is everybody's responsibility in an organization and not just teams which implements. Guardrail, for example, right? So a software that is, let's say, using agentic AI or generative AI being developed for, say, a bank, right? It shouldn't answer things related to cooking, for example. It shouldn't answer questions related to anything else, right? So these are something called guardrails that a team implements, for example, so that your system, first of all, doesn't output something which it's not expected, and only answers the things that is relevant, right? So all these things you have to evaluate, and it's not just one team, one person that is responsible. It's everybody's responsibility in a company. That's all from my side. If you have any other question, there are some references that I put together, and I believe these PowerPoints will be shared. Yeah, you feel free to connect with us on LinkedIn. These are the URLs. Any questions anybody has?
Yeah, we'll be around. Maybe if you have any questions, you can just catch
Yeah.
up. Thank you.
Thank you.